In this video, we are going to be looking at the cost or to store or to not store derived data. So the cost to store it versus to not store it. So one of the great tools that we do have access to now is a lot of the data warehouse updates in Microsoft SQL Server that we've had for quite some time. So whether it's in-memory tables, clustered column stored indexes, etc. So the good news is that if we're using the latest SQL servers and we have an environment that can handle it, we won't have to face this problem quite as much as we used to anymore, except for smaller environments where we have very strict, let's say, space requirements, or let's say very secure environments where we're using space as a security technique. So on the left-hand side of our screen, we have a table that has derived data in it, and our example will just be an identity. And then on the right-hand side, we have a table that we derive the data. So we don't actually have this ID column. We are actually going to derive it in our queries. And so this is just kind of an example of something that we could do. There are other examples. For instance, in finance, you have like the moving averages. That would be like storing it versus not storing that data. Okay. So the very first part of this discussion is, what is the cost of storing derived data? And keep in mind, when we talk about cost, we're not just talking about storage, we're also talking about performance. For instance, if we store the derived data, let's say we put it in our in-memory table, or we put it on our disk table, that's going to use space, whether it's in memory or, of course, it's going to use space in terms of on the disk. But the problem is, if let's say we don't, we're going to have a performance cost when we pull the data, right? So let's say we derive it on the fly, we are going to have that performance cost. And keep in mind, if we're doing something like a moving average, we're going to have to refer back to the table. Of course, we might do the moving average in a middleware application like, let's say, C# or whatnot. That'd probably be a lot faster, but there's still going to be a performance hit on that. Okay, so the next thing that I would consider if we're looking at this is the use of the derived value. For instance, how often is it used? What is it used for? Do we have any, let's say, tracking of the frequency of this by customers or clients? For instance, if it is very frequent, then the advantage of storing it is definitely large, okay? And then the amount of derivatives. Keep in mind, with derived data, there may be derived data on top of derived data on top of derived data. We probably have all worked in environments where we've seen that. It might actually be in our best interest then to store at least some of that derived data, okay? And derivatives on derivatives especially, you probably want at least the base derivatives to be stored. And then we have to consider whether our environment is OLTP, so we have high transaction processing. Keep in mind, in that type of environment, these heavy queries may cause disruptions with that. So we want to be careful how much our queries are deriving data in those environments. Whereas in OLAP environments, we typically have timed loads, not always, but we have timed loads. So we have an environment built for heavy queries, right? For more expensive queries. And then of course we have the hybrid environments, which are a little bit more tricky, but also more common. I will say with derived data now, ever since Microsoft introduced clustered column stored indexes, that's going to be one thing I'm going to look at, especially if the derived data, and most of the time it is, for reports. Right, there are derivative data where we deal with this in, let's say, ETL transforms, and they may be part of the middle product before ending up in the final report. So those are a little bit trickier. But when it comes to any type of final report, when it comes to derivatives, I'm going to prefer the clustered column store indexes. And if you think about how the clustered column store indexes store data, it's unlikely when we're talking about, especially numerical derivatives for sure, it's unlikely with numerical derivatives that you're going to take that big of a hit in terms of storage cost. It will drastically reduce your storage cost. The thing you don't tend to see clustered column store indexes do well is like your varchars, and doesn't do super well with GUIDs, and that makes sense. There's definitely more unique values, but when it comes to numerical values, it definitely has a huge performance boost on that. So unless we're using some version that doesn't have it, and there are some environments out there that are like that. They're using much older versions of SQL Server. That would be something that I'll look at. So these are just some considerations when it comes to storing or not storing derived data. I will say that right now, especially with the tools that Microsoft has for us in SQL Server, I'm going to favor storing it unless we're talking about a significant amount of derivatives where we have derivatives on top of derivatives on top of derivatives on top of derivatives. I may store some of the base derivatives and then go from there. I will also say that more than likely I'm not going to, in this example I use a row number, but more than likely I'm not going to be deriving some of the more advanced data in T-SQL. I would be using a tool like, whether a programming language, I should say, like C#, Python, those type of things, any type of middleware language on top of it. And it's because they do have tools built for performance when it comes to, loading a data set in an object and then going from there.